Good afternoon, members. Hope you're doing good. And can someone confirm if I'm audible?
Yes, you are audible.
Yes, thank you, Mr. Probaka. You're welcome to
Thank you.
Uganda Swag. And this is our 24th session ever since Uganda Swag started in 2023. So, you're welcome to present Uganda Swag with, with the title that aims as passing CSWA exam, because most of the members have CSWA exam that we activated them last time, and also CSWP. So members, you're welcome to Uganda Swag session, and to the members who are not from Uganda, you're also welcome. So Mr. Probaka, you can take on. Thanks.
Thank you, Troy Edwin. Thanks for the wonderful introduction. Good afternoon, all. I welcome you all for today's session. So I'm sharing my screen. Please confirm whether my screen is visible.
Yes, sure. It is visible in the PowerPoint
Fine.
mode.
Yeah, fine. Okay. So first of all, I thank Uganda SolidWorks user group team for giving me this opportunity to present on CSWA exam certification session. So about myself, my name is Prabhakar. I'm from India. I'm a SolidWorks champion. Also CSWE. I have completed my CSWE, and my specialization is SPM and automation domain. So I did my post graduation in machinery design. So the software proficiency is SolidWorks as well as 3D Experience Works. So today we are going to see next 2 hours on CSWA exam preparation. How we will take it forward is, if you have any queries, you can drop your queries in a chat box, or at the end of the session, we can have a Q&A session where I can able to clarify you. In case if there is some queries, you can feel free to connect me through LinkedIn, or you can drop me a mail. I can one-to-one also I can able to support you on completing this CSWA exam. So starting with the exam preparation, CSWA examination is a Certified SolidWorks Associate exam. That's what CSWA mean. It's the very basic or entry level certification in the SolidWorks certification. There are so many certification are there. So in the design, the next level we call it as a professional. Then there is an expert. So these are the in the design. When we see the same way, there is so many certification in 3D experience side and simulation side. There are separate certifications are there. Everything. So our first step today is we are going to look about CSWA certification, Certified SolidWorks Associate certification. This is a first milestone you will be earning when you learn SolidWorks. You will be certified directly from Dassault system. The exam will be conducted directly from Dassault system, and certification will be provided directly from the Dassault system. The main advantage here is this certificate is globally verifiable. Irrespective of country you are in, each certificate will have an ID. With that ID, if you put it in the internet, directly you can able to verify it, and also your name will get popped out in when you complete the examination in the Dassault system website itself. So those kinds of benefits are available when you complete this CSWA certification. So first, before going to CSWA certification, there will be few of them who is completely new to SolidWorks. For them, I like to explain what is SolidWorks, because some of them might be students from the colleges, or some of them will be very new to SolidWorks, who will be eager to learn SolidWorks. If someone asks you, once you learn the SolidWorks, what is SolidWorks, how to explain them, or how to tell them in a simple way what this SolidWorks, because anyway, the aim is you are going to complete CSWA certification after this session. So before that, you should know some of the terminologies of the SolidWorks. That's why I thought of telling you. SolidWorks is nothing but a feature-based 3D modeling tool. A feature-based 3D modeling tool is nothing but every operation you do to build a model, either you add material or you remove material, each step will be recorded as a feature. That's what we call it as a feature-based modeling tool. Okay, it's a feature-based modeling tool with parametric solution. Parametric solution, here we call it is nothing but when you add a dimension or remove a dimension, what it will do is you can easily edit it. I will show you in the SolidWorks. So this is the SolidWorks screen. Most of them might be aware, but whoever is not aware, I'm just telling you, I'm just entering into part environment. There are 3 different environment: part, assembly, and drawing. So I'm just entering into part environment. What is in the part environment is most of the products which is around us is developed with multiple parts are getting assembled together. For example, we take our mouse or laptop, it's not made up of single part. It has multiple parts. For an example, laptop, if you have, the screen is a part. Inside that, a PCB is a separate part. And if you take like that, so many parts, keyboard, each key will be a separate part. Finally, when it comes as a product, multiple parts are assembled together. That assembly will be done in the assembly environment. But initially, each component level will be developed in the part environment. Then once either part or assembly has been developed to manufacture it, if manufacturing drawing is required, then we'll be entering into the drawing environment. This is how the SolidWorks works. So now there are few components, we can say, like kitchen equipments, just a spoon or a cup or a saucer, which entire product has been built with a single part, but it is very, very, very rare. But most of the products around us is made up of multiple parts, and it is being assembled together. Now coming back to the SolidWorks definition, what I told is SolidWorks is a feature-based modeling. So what is feature-based modeling is nothing but, now I'm just creating a block. Just giving a randomly, I'm taking a dimension. I'm not worried about the dimension. What I did is I created a sketch and I added a material. I added a thickness. So this is what we call it as a feature. Whatever the operation I made, suppose if I remove a material over here, so again it will become a separate different feature. So you can see here, there is nothing. Initially, I added a material, then I removed a material. So this is how I keep on building a model. Likewise, whatever the operation I do, either adding or removing, it will be recorded as features. That's what SolidWorks is called as a feature-based modeling. And also the second point I told is SolidWorks is a parametric tool, which is nothing but, suppose if I want to change this dimension, if I just click on this surface, it will show all the relevant dimension like diameter, the thickness, length, width, everything it will show. Suppose if I click on the diameter, all the diameter related dimension it will show. Suppose if I want to add the thickness, I change the thickness, I can directly change here. If I change the length or width, I can double click and I can change it. That is possible in the SolidWorks. This is what we call it as a parametric property. The third property SolidWorks it has is associative property. As we seen here, there are 3 different environment: part, assembly, and drawing environment. If I make any changes in the part, so likewise, if I click when I updated here the dimension, right? Likewise, if I do some changes in the part, it will automatically get updated into the assembly environment and also in the drawing environment. I need not to individually change in the assembly environment separately or I need not to individually change in the drawing environment separately. At the same pace, if I do some changes in the assembly environment, the part environment and the drawing environment will get updated automatically. Dimension will get updated automatically. This proper call it as an associative. So simply the three terms you need to remember is it's a feature based, it's a parametric, SolidWorks is a parametric, and it has an associative property. So these three terms you remember and build your own sentence. That's what how we can define a SolidWorks means. Okay, now moving on to the slide again. So coming back to the CSWA certification exam, in this exam time limit is 3 hours and you have overall 14 questions will be there and 70% is required to pass. In case you couldn't able to crack the exam, you have to, there is a waiting period of 14 days. Just you have to practice again. The waiting period is provided. The reason is you have to practice again completely and you have to well versed on the tool. Then once again you have to take the exam after 14 days. So again, if you get the minimum criteria of 70% of mark out of 100%, 100, or you have to get 70% of the mark. Once you are through, then you will be awarded the certificate online immediately without any delay. But again, in case if whoever has been failed, again they have to wait for 14 days. This 14 days waiting period is there. Whoever is being failed, how many times is been failed also, that matters. And the software required is now the present criteria is 2000 software to SolidWorks 2011 or later it should be. And the system configuration is as recommended by Dassault system. So Dassault system has recommended a SolidWorks system configuration. The Dassault system website itself, the website is been shown here. So in the website you can go and you can, if you see, it will show the what is the hardware requirement like Windows, what should be the operating system, and what should be the processor, RAM capacity, graphic card, what should be a system recommended graphic card, and the graphic card drivers, everything it will be available here. So the model number, whichever is there as per your either AMD or Intel, so whichever the graphic card you have, you can select and it will get you the details, acceptable graphic. So not only the this one, the software, the SolidWorks software should be true, but also the system also should be have a recommended system so that you can, without anything, you can complete the exam. And the main thing is you cannot pass, you cannot take break. Suppose once the exam is started, the timer will be keep on running until you complete the exam. You should not take a break or anything. You should focus on the exam and you should take the exam. That is also the key thing you have to take care while taking the SolidWorks CSWA examinations. So coming to the topics you should need to get mastered is the sketch entities, the lines, rectangle, circle, the basic commands, because as I told, this is the basic level of the entry level of certification, I said. So some of the basic commands only is being listed out here. Most of the sketch tools and boss extruded tool, 3D extruding tools, which is extrude, revolve, sweep, and lock, fillet, chamfer, so and linear and circular patterns, dimensioning, and mass properties, material, and how to insert the components in the assembly environment, standard mates like basic mates, coincident, parallel. So all these things, anyway, I'm going to show you a demo also, no worries. Just to give you an overview, this slide is being provided. And regarding drawing views, you should have a thorough knowledge, and annotations in the drawings also, you should have a thorough knowledge. These are all some of the skills you need to master before taking the CSWA exams. So coming to how, as I told, total there are 14 questions will be there. So out of these 14 questions, 2 to 3 questions will be on 2D drawings from the 3D model. So a drawing views will be provided, and from the view, either it's a standard view or section view, you should be able to choose from the multiple choice question will be given. From there, you should be able to choose A, B, C, D option will be given. So you should choose. You'll be asking some broken view or some half sectioning, full sectioning, some kind of a section view they will be doing, and they will be asking a question. So you should be able to choose the correct answer for that. That kind of questions will be, you can expect 2 to 3 questions. Then 7 to 8 questions will be there on completely part modeling. You have to create a 3D models from 2D sketches, then where you will be tested with line, circle, or ellipse, and center lines you may will be using, and so many sketch tools like trim, offset, convert entities you'll be using. Then feature tools like extrude, revolve, and sweep, loft, which we have seen here in this slide. The same thing has been repeated here, so I will skip. The finally, what you have to do is you have to create the 3D model. You have to measure the mass property, and you have to assign the material also, given material, and you have to measure the mass property, and you have to answer the value. So there will be hands-on modeling will be there, and it is also multiple choice question. If once you do the modeling, once you assign the material, you have to find the volume or the mass of the body. That will be the expectation from the questions. That will be there from 7 to 8 questions. Then when it comes to the assembly modeling, there will be 3 to 4 questions you can expect, where the parts will be given, individual parts will be given to you as a zip file. So from the zip file, you have to extract it, and you have to build the assembly as per the image provided by the during the exam, and by using the mate commands like standard mates like coincident, concentric, parallel, tangent, and you may have to create axis, planes, everything. Then you have to find the center of mass. Center of mass you have to find. That is the expected thing from this question also. So 2 to 3 assemblies you may have. Sometimes one assembly you build, there they will be asking you to change some value, and you have to go with the next assembly. That's how it takes. So these are all the 14 questions expectation. So from drawing side, you will be getting 2 questions. It's completely seeing, they will be giving a view or the image. By seeing the image, you may have to answer it. The second, the part modeling, where you have to completely do hands-on part modeling. So you build the model completely. Then there will be a multiple choice. You apply the material, measure the mass, and enter the correct answer out of 4, which is the correct value that you have to enter. The third will be the assembly, where you will be given the individual parts. You need not to build the parts on your own. You need not to build the parts on your own. The parts will be given to you for during the exam itself. You have to just download it. You just build down, assemble it, insert the component in the assembly environment, and build the assembly in the assembly environment. Then finally you measure the center of mass. This is how the CSWA exam questions pattern will be. Before going to this, we are going to see some of the exercise here. This anyway, we are going to see, since we have some time, what I want to tell you is, you better practice this example, which is being provided from Dassault system itself in the SolidWorks website. Okay, for this, to access this, you need not to do, you just have to do types SolidWorks sample exam. If you type like this, you can able to download this. Once you give download, automatically this will get downloaded. Okay, here complete steps will be provided, like how to create, how to take up the exam, everything will be provided here. So what and all the certifications available, like associate, professional, and professional advanced, then expert, then PDM administrator. So everything, what and all the tools you need to master. Then for preparation, yeah, what and all the resources you can use. So the tips to take up the exam, Everything will be provided here. Okay, here also for practice test also, you have to run the exam. The timer will be running it. So the condition will be real time, and within 2 digits you have to give the accuracy. Then this practice test you'll be given 90 minutes time. For this, how to start the exam, everything will be step by step. It will be given here. Now I will directly take you to the questions here. So, as I told, there will be 2 to 3 questions will be there, where some images will be provided and option A, B, C, D will be provided. You have to provide the answers to it. So this is related to the drawing. The same way it is being provided here. In this question, a 3D model is being provided. A small area, a spline has been used and created, and it is being cut and shown here. So to create drawing view B, this is the drawing view B, it is necessary to sketch a spline. This is the spline they have sketched on the drawing view A, and insert which SolidWorks view type. What is the name of this view type? So the options given is A is section, B is crop, projected, and isometric. For this, the answer will be the B, crop. Crop will be the answer for this particular question. The second question, this is the image they have provided. For this image, to create drawing view B, this is the drawing view B. A necessary sketch or spline. Here you can see here in the isometric front view, they made a spline on a drawing view A, and they made a cut and they have shown here. Okay, what kind of sectioning is done here? So there are 4 options has been given, like aligned section, detail, broken out section, and section. The answer will be like broken out section. Broken out section is only the small portion of the area has been cut and it is been hatched and shown. This is called, whenever the hatching is come, that time you should remember the word sectioning. So this view answer will be broken out sectioning. Likewise, you'll be answering 2 or 3 questions. Then you'll be given like a part model, like given. So what you have to do is you have to draw the model, and there will be the key thing is question here you have to study is unit they have given as millimeter gram second. Okay, decimal places 2. So 2 decimal places you need to consider. After the whole number, if there is some decimal places, when you specify the answer, up to 2 decimal places you need to specify. Then the material they have specified, and automatically when you assign this material, make sure this density is being available. Then A value and B value and C value, 3 different values. Sorry,
আমার লাগে না, আমার এত কিছু লাগে না,
I
আমি
think
লড়া দিয়ে
someone is speaking. Sorry for that. So A, B, and C is been given. A, B, and C is nothing but A, the value, instead of giving here the dimension directly, they ask you to consider this dimensions. Like for assume A as 81. The same way for this B. For this B, you have to assume it as a 57. And C is nothing but the thickness. This thickness, you have to assume it as a 43. So considering all these dimensions, you have to build them part and you have to assign the mass. This is what is been expected. So now we will assume it. It's like 5:53 here. It's showing in my clock. It will be differing for you. So we will take like you have to fix a time. So this to build, you should not take more than 5 minutes. Likewise, you have to fix a time and you have to start building the model. Now I'm going to tell you, I'm exactly like 5:55 here. I'm going to start. Just before 6, I like to close. So how we are going to do is, I'm going to take a front plane and create the sketch. How I'm going to create the sketch? The straight line, chamfer, straight line, chamfer, straight line. There is an angular line and there is a radius, straight line, chamfer, straight line, chamfer. Likewise, I create. Then what I will do is I will extrude it to this thickness. This is the idea. For doing this, what I have to do is I just enter into SolidWorks. So I will close this file, new. I'm entering into the part environment. I can just click and give OK, or double click and OK. As I told, I directly enter into front plane and sketch. There is an option here, or some people will do go here, take a sketch, then select the plane. There is nothing right and wrong. Whichever is convenient to you, you can follow this. What you can do is I will start with the chamfer straight line. There is an angle, and there is a radius. For creating the radius, I just come back and touch here. It will help me to create the radius. Then there is a straight line, then chamfer, straight line, then chamfer, again a straight line, then one angular line, then bottom there is a straight line. Then again I will start from this side. I don't worry about any of the dimensions. I'm just creating the profile. Again, as I told, to create a radius, just once again go back and touch here. It will help me to create the radius. Then go for a 3-point arc. First point, second point, and radius. So once it is closed, you can see it's a shaded area. Now you started giving the dimension. Like A, it is been given as 81. So that dimension I'm going to provide. So end to end is 81. Next, B is 57. Okay. This height. Next, this height is 1932. Okay. This chamfer, they have given 45 degree and 7 mm. You can see it. This is also 7 and 45 degree. Okay. You can see it, it is getting black, which means the dimensions are getting constrained. Okay. Then this end to this face, it is 14 and 10 degree. So what I do is I select this point and give 14. And this angle, I specify it as a 10 degree. And here they have given it as a tangent and radius 19. So already the tangent command is there. Radius 19 I provide. From this space to this edge, it is 29 degree, 29 mm, sorry. Okay, then this angle is 45 degree. And this dimension is 5 mm. 5 mm has been given here. Okay, then this length, they have given it as a 24. Till this point, it is 24. Okay, then the pending is this this area. From this edge, this point, starting point is 29. Since it is not constrained, I can easily drag and position it. Okay, Then finally, this should be tangent, radius 5. This is already tangent. So what I do is this and this, I make it as a tangent. Then this center point, it is somewhere here. This I hold control and select this point and select this line. I give it as a coincident. Okay, here they have given the dimension as 19. So what I do, I select here, give this dimension as 19 mm. Okay, and also the radius value they have given. The radius is 29. 29. And this radius is 5. The one last thing I missed is this circle. So from this edge to this center, it is 14 mm. And this distance is also 14 mm. And the diameter, that is also 14. Finally, I extrude it to the thickness. What is the thickness? C is 43. So feature, extrude 43. Okay, I created the model. Finally, I have to, as I told, within like 5 to 6 minutes, I could able to complete it. This time conscious also you should be taking care when building the model. Then finally, the material they have given is AISI 1020. We can just right click here, apply edit material. You can go 1620. Sorry, 1020, right? 1020. So once you select, automatically the density also will get updated here. You can see here the density value. What is been given here is here gram per mm cube. Here it is in kg per mm cube. That's why there is a difference, but it is same only. Then finally, you go to evaluate mass property. You can find the mass, and they have asked after 2 decimal you have to enter. So 939.54. So there is some options A, B, C, D. 4 options were given. Out of that, D will be the right option. That's what you have to select as your answer. This is how you have to do the part modeling task. Okay, so here, what and all the things you need to consider is, one is the time management is key. So once you saw the model, how you are going to build, either the model should require extrude, or it requires revolve, or it requires sweep. So what command is being required, that you need to plan. At the same time, which plane you are going to build, how many planes you are going to use, and you have to build. That is important. Likewise, if I go to the second question, what they do is the same model, I have to do save as and do some changes. Like earlier, A was 81, B was 57, C was 43. That I have to update it into 84, 59, and 45. For that first step, what I have to do is I just have to save as this part. I will just do save to PC, then save as new I do, and save a new part I take. There I will be editing. That is the procedure. So since I'm demonstrating it, I'm not saving it. I just directly take it. So how what I'm going to do is, once I click the place, automatically I get the dimensions will be highlighted. Like 84, 59, 45 was the earlier dimension. The new dimension required. $84, 59, 45. 45 is nothing but the thickness. Instantly I rebuilt it. Then evaluate mass property. The mass value 1032.32. That is the answer. So here sometimes they will not give the options at all. They will be just give the fill in the blanks kind of thing, a blank will be there. You have to enter your value. So there you have to just measure this value and enter this particular value. Then you will be answering the question. Same way, this will be the next question. This is also a very simple question. Once you build a model, you should not take much time. Okay. This you may take like another 2 or 3 minutes to complete this exam. Here, what they have asked is, one you notice is this hole is being added. This new hole is being added, and there is a cut over here and cut over here. Okay, the dimension also they have provided. The cut they have given like A, B, C value you have to assume first. So what is the A value? A, B, C they have given 86, 58, 44. You do one thing, you just do the save as and take it as a new model. 86, 58 and 44. Okay, once it is been done, then the first step is I will cut this dimensions. So I just go to sketch, select this face now. This face will act as a sketch. Now I randomly, I'm not selecting the midpoint. Away from the midpoint, I just randomly select, make a line. Then I give this dimension as a 52. This has been given as an input. Here it has been given as a 52. That's what has been taken. So now I use convert entities. Convert entities command. Select this edges and converting it as a sketch. Then the excess portion I'm trimming it off. You can see here it became completely shaded. At the same time, I'm going to cut this portion also, this 19 mm. So what I will do is I take a line, okay, once again I go to convert entities, select this line, then I just go to trim entities. Since both are the same depth, I'm cutting it together. So I select blind and the depth of 19 mm, I made a cut. The very next cut is this portion, this area, or 41 they have given. The first, the one constraint I have to do is this is in the same line. So where I will draw the sketches, I draw from this area only. 3-point arc I take. Okay, don't select at the midpoint, which is showing it here. Just somewhere outside you select here. So what the consideration I told, this and this line should be coincident. Then you give the arc radius. Arc radius is 41. Okay, then from the top, this edge is, bottommost edge is 36. Okay, then once again I go to convert entities and trim entities I select. Now one thing to do, I should not cut directly on this face. Suppose here you can see here in the isometric view, you can see it here. They have clearly given from here it is 12, 24, and this dimension. This dimension is nothing but C over C is 44. 44 minus 24, 12, and this will be automatically 12. So what if I do extrude cut and cut it 12 mm, if I cut it here, you can see here it is not correct. This is not at all correct. So what you have to do is here you have, instead of sketch plane, you have to use offset. Okay, so here the offset distance, you enter it as a 12. Okay, the direction of the flip you can give. It is not cutting exactly here. It is getting offsetted and it is being cutting here. And this dimension is 24. So that dimension also I provide. Okay, if I measure, this dimension is 8. Sorry. So the offset distance is wrong mine. So I just adjust it 8 mm. This will be 12. This is 24. And this will be 44. Okay. So this is nothing but 44 minus 24 plus 12. That is nothing but 36. When we do, this will be 8 mm wall thickness. So only the missing element is this hole, 14, 14 and 11. Finally, I do that. Mm. Again, vertical dimension also 14. And this will be 11. So feature extruded cut through wall is the part is been completed. So the question here is I have to apply the mass as ASA 1020, which is already assigned, overall mass of the part in gram. So I have to put evaluate mass property. This value I have to enter as my answer. Likewise, the question will be keep on adding up. The next question, if you see the same question, I have to do save as and make a cut over here like the profile shown, make a profile over here like a profile shown, maintaining this dimension. This you can practice on your own. If you face any issues, you can let me know. Now I will directly go to the assembly modeling. I just skip this. Here itself in the back, if you will find the answer key also. So which is the answer, what is there? So this 628.18, that's what we also got. The next answer will be like this. They have given, you just model and you can check it on your own. Now I will, due to the time constraint, just skip that. We will move on to this because still I want to show all these things also in the PPT. The main idea is before 6:15, I thought of completing all this. Anyway, I still a little bit extended. No problem. Around 6:20, I like to come out of this session. I hope so far it is good. Any questions? Fine. So far there is no question. If you have any questions, please post it there. Now we will move on to the assembly modeling. Okay, so this assembly modeling we are going to create. For this creating of this assembly, all these parts will be provided. The BOM has been shown here. Ballooning they have done and they have shown. This is 1, this is 2, this is 3, which means item number 1, which is shown in a green, it has 2 number. Item number 2, which is shown in blue or cyan color, it has 3 quantities used in assembly. Item number 3, a link part, which has been shown here, which has been used 4 quantities in the assembly. And they have given 3 angles, A, B, and C. You can see here the values of A, B, and C has been given. Here they don't ask you to assign the material also. They have clearly mentioned download the attached zip file, open it. The attached zip file will be given to you. You have to just open it. You have to start building assembly, and they clearly mentioned pins are mated concentric and chain link hold, no clearance is be done, and end faces are coincident to chain link faces. This faces, all the faces, it's completely coincidence they have given, and all the pins are concentric, they have clearly mentioned. And also these faces, the end faces also, the top face with this, everything is coincident. These are the conditions they have given. The value of A, B, C is been given. This value, this angle, this angle, this angle is been given. Finally, you have to find center of mass of the assembly. Okay, if it is a 2D, we call it a center of gravity. Since it is a 3D, we have XYZ position. We call it as a center of mass of the position, where the entire mass will get balanced. The point where the entire mass will get balanced in a simple way. So they have given XYZ position. The key important thing you need to identify is, you need to notice is this coordinate system. X, Y, Z direction, they properly, they have clear position that you have to take care. Okay, now we will start building this model. Since I already have these three parts, position 1, position 2, position 2 and position 3 already have. Let me start building the model. I'm just closing this. I'm not saving it since it's a practice or demo for you. But what I suggest is each and every model you make, you create one folder and start saving it. Okay, here I have three models, long pin, short pin, and chain link. Okay, so first step is I will enter into assembly environment, file, new. I just select assembly and give OK. Okay, I enter into the assembly environment. Here you can see a simple representation, a blue color. That is nothing but the assembly symbol. That is the difference. In a part, this blue color will not be there. In the assembly, this blue color will be there. That also a simple thing which you can remember, that you are in the assembly environment. Okay, then first step is insert component. The first component I'm going to insert is this long pin. Okay, the long pin, this long pin I insert. Before inserting, the orientation I am changing it. Okay, this is the orientation I want. The second thing is I want the reference to be matched. So first step is I just click here, I get this feature tree and I select this origin. Why I do this? You can see here, this is my assembly origin and my part origin. Both are exactly inline. If I do it, just insert component, long pin, I randomly change, and if I randomly I click, I'm not going here and giving origin, and if I click here, what will happen is, this is my reference origin of the assembly environment. This is my origin of the part environment. There will be a difference. That's why what I suggest is, whenever you insert the first component alone, you need not to, once again I will do it and show you. I will undo it. The first component, once you insert, you have, after setting the orientation, just click on this area, feature manager design tree. Just click here. This will get open. There is a small arrow you can see here that you expand. You can see this origin. You can place it over here, so that this will exactly the front plane and front plane, top plane, right plane, everything will be aligned properly. That is the reason I ask you to do it. So this will be one of the best practice, because why I suggested this is, when you are finding the center of mass, that will be easy. Here they have given a dot. Using this anyway, we are going to create a coordinate that anyway I'm showing you. But still, apart from the exam, this practice will help you to build a good assembly practice when you are building an assembly. Then the second component, I just insert this chain link, randomly I click. Now I need not worry about the origin and all. I just randomly click. I select mate. Once I select both the touching faces, when I select, automatically it will select as coincident. I need not to select anything. The same thing I select here and select here. Okay, here one thing I want to do is, this should be equally, now it is free to rotate. This rotation I want to arrest. So once again I go to mate, I just go to advanced mate. There is an option called symmetry, where I select the plane. This front plane I select, then two faces I select. Now I constrain the rotation also. Completely the part is constrained. Okay, the next step is I insert the second part, short pin. Once it is inserted, I just go here, select the mate, select this and this and face, two faces, I made it touching. So once again, I need this link part. So I need not to insert. I have holding control, drag and drop in the screen. It will copy, help me to duplicate the part which is available in the assembly. Hold control, just drag and drop without leaving the control. You can duplicate the part. Same way, if you want to delete, select here, press delete button in the keyboard. It will allow you to delete also. Just go to make it concentric. It should be concentric with respect to this. Then this face will be touching to this face. Then they have given the angle, inclined angle. So if you see here the drawing, from here there is an inclined angle and they have mentioned it as an A. A is 25 degrees. You can see it here, 25 degrees. I have to make it, go to mate, select this face, select the angle, type 25 degree. If it is like this, don't worry, remove that flip or change the mate alignment and remove the flip. Okay, this 25 degree, you keep it as it. Just play with these two things. Either if it is there or if it was earlier like this, don't worry. Just change it and remove the flip. Just 2-3 times if you work out, you will get this option properly. Initially, you may struggle. Just 2-3 times you just try this. You only will get automatically. So this is done. So for here also, I just copy this just by holding the control. I dragged it. I just go to, mate. Then I select the faces. Okay. Once again, I duplicate this by holding the control. I just dragged and drop this part. And select this face will be touching over here, this. Now, there is an angle over here also. If you see this, you can find here B, they have given the angle as 125 degree. So first randomly you select this two face, go to here also, this angle you can select, type 125. Okay. Without flipping itself, I got this. So I just given it okay. I made this angle. Third is this link I have to attach. So what I do, first I copy this pin. There is one more option also I will tell you. You just right click here, you will find copy with mates. Then you select this face and automatically, if you want to do it multiple repeatedly again and again, this copy with mates command will be helpful. Okay, and once again, select this. Same way, select this face and this face, angular. Here, the angle they have given is 130 degree. 130. So here now I have to play on this flip. Okay, just activated this and click this flip. It became correct. And mate, select here. Done. Okay, the assembly is completed. So one key thing you have to identify is this, the reference XYZ position with respect to this, you have to identify. Now, if you directly go to evaluate, it will take reference as this one. So what you have to do is, they have given a small dot over here. Or the origin. Okay, insert reference geometry coordinate system. You just mention x-axis. X-axis is towards this direction. So I select this line. Then y-axis. Y-axis is, you can see here, towards upward. So I select this line. Okay. And z-axis, z direction is towards front. I select this line. Activate this. You can flip it also. Y direction is same, and Z direction I can flip it. X, Y, Z. Now it is perfectly matching, right? X, Y upward and Z towards front. Okay, you can see here Y is upward, X is towards front, Z direction. All three coordinates are now matching. So go to evaluate mass properties. Here default you select coordinate system 1. Okay, recalculate you provide. Then you will find the value 348.66 minus 88.48. So option A is the right answer, 91.40 minus 91.40. Only this coordinate point, many of them will be finding difficult. I will do it again. I will just deleting it and I will do it again. Okay, here you have an origin. You select this origin as a reference. It will be closed like this. What you have to do is you just open it, just select this origin point, go to insert, reference geometry, coordinate system. Then here they have given the XYZ positions. X should be in this direction. Y is towards up. Arrow Z is facing towards me. Likewise, I can able to see in the drawing. The same thing you just replicate in the lines. X coordinate should be parallel to this edge. If it is turning, just reverse it. Then Y should look upward. Just this line I select. Okay, Y is towards upward. Z axis should face towards me. If it is facing towards the opposite direction, just again flip it off. You will find this coordinate system. Just ensure this X, Y, Z coordinate is matching with this coordinate system. Then finally go to mass properties. You'll be in the evaluate mass properties. You'll be finding the center of mass. Under center of mass, you'll be finding the values of X, Y, Z values that should match with the options provided here. So whichever the option is matching, that you enter as your answer. So that's how you have to answer your question. The next question is the same thing. This ABC alone is getting changed. Here it has been given 25 degree, 125 and 130 degree. So here 30, 115, 135. So simple. What you have to do is just expand the mate. This is the angle 1. 25, I make it as a 30, 115 degree. B is nothing but 115 degree. Angle 2. If I select here, 115. And C angle here, you can see it 135. 35. Once again, I go to mass properties. I should change the first thing. I should change the to coordinate system 2. This is the coordinate system 2. The name you can find it here at the bottom. You can see it here. Coordinate system 2. The name, this should be activated. Then you should then find the center of mass. This value you have to enter it as your answer. So here they have given this value. This will be properly matching here. 327.67 minus 98. Suppose here one thing I want to tell you is you can override the settings. Number of decimals. If it is 0, if it is 1, it will be showing like this. But minimum you need to enter 2 values. So go to option. Here you click on this use custom setting. Here you can change whatever the units you want. Decimals, make sure 2 is active, so that you will be getting, after that 2 decimals you'll be getting, that you can enter as your answer. So another 1 hour left. We will move on to the PPT. So hope so far, if you have any queries, please drop in the chat box. How do I set my SolidWorks so that when I click on the model, the dimensions are shown? When you click on the model, automatically as a default, that property itself, we call it as a parametric. You need not to do anything. This is an imported model. For example, this is an imported model. This is not built. Okay, as I told, the SolidWorks, this is not a feature based. It's not built in. It can be built in any of the software. Like, then finally it is being saved in SolidWorks. If I click here, it will not show. But whichever the model I build in SolidWorks, automatically it has a feature that when I click on the model, automatically it will show the dimension. That's what I have shown earlier. Once again, I will show this to you. This Kagambe Innocent. I hope I answered your question. What would be the problem if I draw the first model as required and assign the material, get the answer similar to one in the multiple objectives? When I move on the next part, the modification, I change values assigned to the global variable. Yes, global variables is, you can use the global variables and you can change the values there. That is also that is the easiest way, and error proof way also, that you can follow Mr. Linda Bills. That option is also good. Also, do all the questions carry the same mark? No. When you build a first model, the weightage of the questions will be high. When likewise, when we saw here, like this, choose the best answer for these questions and all, usually it will be like 5 marks. And when you build building the models, will be having some 15 marks. And when you're changing the dimensions like ABC, usually it will be having like 10 marks. Slightly 5 marks will be reduced. So once again, when you're doing some major modification, this type of questions will be having 15 marks kind of question. So when you select, automatically they will, in the question itself will be shown how much marks will be assigned to the question itself. Session is recorded. Yes, the session is recorded. You will be shared with all the PPT and also whatever the slides I used and whatever the parts I going to use, everything will be shared with you. Technical part, Mr. Tanveer Rahman asked, I am quite good with modeling part and assembly, but I struggle on technical part like broken views, center of gravity, what I do, resources. Nothing, just practice makes you perfect. In a simple way, Mr. Tanveer Rahman, I'll try to explain you. You need not to take complex part. I'll take one simple part and I will explain you about the center of mass. How you build the mass or how you build the assembly, that matters. Suppose I will take a block of a cube. We will assume a cube of 100 mm by 100 mm by 100 mm. So all 3 dimension, it's 100 mm. The reference is not properly linked, so that it's showing like this. I'll link the reference. Now, if you see here, I will apply the material also. Plain carbon steel, roughly, quickly, for quick understanding, I'll apply. If I go to evaluate mass properties, you can see here, the x-axis, it is 0. You can see here, refer to this coordinate system. This triad they have been shown here. X, it is been 0. Why it is? You can see the front plane. How the front plane is distributed. Front plane, if I measure to this face to the distance, exactly 50, the same front plane to this direction, exactly 50. But at the same time, y is also 0. Why? The reason is the top plane, the right plane. the green color is y, which is nothing but the direction, the right plane direction. Measure, this is 50. This is also 50. That's why it is showing 0. But when you see z is 50, why? The top plane is z, which is blue color line you can see here. Why it is 50? The model is built like this is not, the plane is not falling exactly center. But in case if I build a model instead of blind as a mid plane, you can see here all three center of masses will be 0, 0, 0. Why? Because all the three planes are placed symmetric. Just close this and I will select front plane, right plane, and top plane. All the three planes are placed exactly symmetric. That's why we are getting the mass property, center of mass position as Z. So when the same thing, if instead of making it mid plane, if I select it as a blind, I got here 50, Z direction 50. The same thing if I flip it, you see here, mine it will become minus 50. Minus 50. Likewise, if you take some simple basic model, how it behaves, you do some research on your own, so that you can able to understand. You need not to depend on any big training materials and all. It's a basic software. If you start doing like small the exercise I have shown, likewise you take some known, take a cylinder or take a rectangular body, something which the spear provides some inclination, and do all kind of practice. If you do, automatically you can able to address this issue, Mr. Tanmir Rahman. Okay, so now I will move on to the next. I think another 45 minutes left. I will quickly move on to the part modeling in CSWA examination. As I told, in CSWA, some of the questions which has been asked in similar questions will be asked. Like here, the model drawings are given. The three different views are being given. And here also, as mentioned, A, B, C, D, 4 different values has been given. So, sorry, A, B, C, 3 different values are being given. Okay, A, B, C values are given, the angle, everything has been given. So you have to build this model and apply the material as EISA 1020, then find the weight of overall mass. So seeing this model itself, you can able to quickly say that this model can be done with a revolve function. Okay, for creating the revolve function, you have to create a closed loop. What you have to do, just make a horizontal line, straight line, radius, straight line, then an angle. You can see here this view, just a straight line, horizontal, radius, straight line, a small angle. Then once again, you have to repeat and close. Simple. Likewise, if you plan it properly, this the command you should plan, the sketch you have to plan. If you plan, automatically you can quickly able to do the design. I go to file, new part, double click and enter and get into new. Then I select here front view. As I told, for creating the radius, you have to just come back and touch it here. Horizontal line, straight line. As we see here, there is a small angle, then horizontal, then again a small angle, then a vertical line, then again here there was a radius. Don't worry about the dimensions. Dimensions anyway, I'm going to give constraints and through smart dimension and control it. Sorry, it was in the PPT. I will go back to the PPT. Overall length is A, 146. Create a center line because I'm going to revolve it. 146. Then B is nothing but 20. Then C is 30. You can give equal command also. Select this two line, give equal constraint also. That also fine. It works. Then this distance, you can see it here. This depth is 2.5 degree, 2.5 mm and 45 degree angle. Is constrained through the depth and the angles. Once I give the diameter value and all, it will get automatically constrained. Okay. So now I go with the diametrical value. The radius is 2. The radius is also I will provide. Automatically tangent constraint is being taken care. I can either give equal or specify the value. Don't worry, whichever is convenient, you can take it forward. Then I go to diameter value. Diameter 50, diameter 80. This is also 50. So I go to smart dimension. What I do, I select here the center line. I select. I decide if I click, I can specify the radial value. I'm not holding any key command. Just selected this line, selected center line. Outside I select. I can directly specify the diametrical value. And diameter 50. The second diameter is diameter 80. Selecting this, selecting here. This is radial. This is the diametrical value. I just give 80. So what I do is I select this line and this line and make it as a collinear. Same thing I provide for this line and this line, make it as a collinear. Okay, once I do it, I just have to do revolve. In revolve, as a default, it's 360 degree. I don't want 360 degree. I want to create a quarter part. So quarter part is nothing but 270 degree. 360 divided by 4. 90 degree will be every quarter in a quarter. So 90 degree will be one first quarter plus 90 degree 180 will be the half of the section. 270 will be 3/4 of the section. This part is being created. Finally, I have to create this slot. For creating the slot, they have given in this view. Okay, so what I'll do, I'll just go to sketch. I use a slot command, create a slot. I can do in a different way also. Circle I can make, lines, but easiest way I felt is this. So the slot command I picked. So the dimension is diameter 6, which means radius 3. Diameter they have given. This is something you should be careful. Other distance is 12. And from bottom it is 7 mm. Okay, you make sure this is randomly you give. Okay, then it is, you can see here it's completely open. This view also you can see here it's completely open. So features, extruded cut, through wall, I select, the slot is being made. Finally, the question what it has been asked is you have to apply the masses AISI 1020 steel. Go to apply edit material, AISI 1020, apply close. Then evaluate mass property, you will find the value 3367.57. So there are 4 options. Out of that, C option is the correct answer. This is how you have to answer it. Okay. The next question is also a part modeling where the multiple sketches is being provided. So here also you have to apply the materials aluminum 1060 alloy, and also E and B values are being provided. Excuse me, just a minute. I'll just see if there is some messages. Fine, everything all good. Fine. E and B is being given. A is nothing but the thickness is being shown. B is nothing but the overall diameter. Overall diameter has been shown, and the profile angle, everything has been given. So here you can see here there is a section done shown. Okay, this wavy line represents short break. This is a full sectioning they have done, and also what they have done in order to save the space in the drawing, because the same thing is going to repeating. There is nothing to show here. To reduce the space, what they have done a short break. So when they break, automatically in this dimension also, this they will make this zigzag line they use. Here they use the wavy line. Okay, this is also one of the thing. There is nothing related to modeling through this, just an additional input. So types of sectioning, you should try to remember. There is full sectioning, half sectioning, broken sectioning, revolved sectioning, removed sectioning, and this one, long break line, short break lines are there. So these 6-7 types, if you try to remember, it will be very much helpful for scoring that 5-mark question. Choose the best answers. That this is an additional tip for you. So we will quickly create this model. With this, we will directly move on to the assembly, because the time constraint, I will skip this thing. We will complete this 2 assembly and we will end this session. Hope you all can bear with me. Okay, Tanvir, happy Durga Puja. Thank you. Wishing you the same. Very informative. Okay, first step is how I'm going to build the model. I'm going to plan. So my planning is I'm going to create this sketch. So straight line, there is an angular line, again one angular line, then straight line. Straight line, immediately you can see here there is an angular line. Angular line, one more angular line, then there is a straight line. I'm not worried about the dimension, I'm just matching the shape. Then the straight line, horizontal is a straight line. Here, there is a straight line and closing the loop. Okay, I close the loop. Now I'm just have to quickly give the dimensions. This value they have given an A, overall dimension. A, sorry, I have to go back here. A is 70. A is 70. I have taken that value. Then rest all I have to provide from here. 20, 45, 45 degree, 15 degree. 20, and this is 45. This is 45 degree. This is 15 degree. And this dimension B minus 50. So B, I have to look backward. B is 1020. As I told, first I draw a center line for revolve so that I can directly give the dimension. Select here 1020. Okay, this dimension 1020 minus 50, because here it has been given B minus 50. Then this diameter is 200. Selecting here, 200 I made. Then this thickness is 30. Okay, then this thickness A plus 20. A is nothing but we have taken here 70. It is completely constrained. There is no blue lines. Everything is completely black. Then I go to features, revolve. I created the model. Okay. So here also the same thing. You have to apply aluminum 1060. Sorry, I'm taking aluminum 1060. I go to aluminum alloys 1060 alloy, apply, close. Then evaluate mass properties. You will find the mass in the gram. 82519.93. Okay, that you have to answer it as a fill in the blanks will be there. No options will be given. You have to just enter the value in the keyboard. The answer will be taken. Next question, the same thing. Previous question only as it is, it's been taken. You have to create this sketch. Okay, you have to create this sketch. If you want, I can quickly do and show you also. So, okay, still time is there. Anyway, I'll do it and show you, because anyway, we have only 2 assemblies. I think I can do it quickly. No problem. I will show you this one also. So the same thing, what they have asked is the material, everything is same. Assume all the unshown dimensions same as the previous question. So whatever we created the previous model, that is valid. All the stiffness are exact same shape. So all the stiffness are the shapes, same shape. Find the overall mass. One thing you should observe in the 3D model is the stiffness depth, and there is a difference in the depth. So that you have to see here. Here they have given like 10 mm depth is there, gap is there. Okay. And also one more thing we should see. Here is from this model is the number they have not given. You just have to count 1, 2, 3, 4, 5, 6, 8, 9 is there. 9 steps are there. So first profile I create, then circular pattern I have to do. The main thing command I am to use is circular pattern. So just go to sketch. First step, you have to save as the model. Don't do in the same thing. Just do the save as and do the save as model. First I create a center line. Okay. Then I create a, I'll take R 3-point R. So this is not tangent. I make it as a tangent. First step. Then I do connect entities. For this and this, make it as a tangent. One more. So Then the dimension between it is 40, 20. 20, 40, and this is radius 60, radius 10. So this is not tangent, that's why still it is in blue. Give tangent constraint. Then exactly matches here with radius 10, radius 10. I just trim this. Better I create a 3-point arc itself. Same time, you can use mirror command that I'm going to show you now. Tangent constraint I provided. Radius 10. I'm going to use mirror entities. Selecting this R, mirror about. Then I just drag and link it over here. Delete this over constraint thing. Trim. Cut it here. Cut it here. The profile has been created. Then I measure here the distance. This distance is 40. So 10 mm should be gap, should be there. I make it as extrude till 30 mm. Profile is being created, single profile is being created. I go to circular pattern. Features to pattern I select here. Make it 9. It's completed. Okay, the 9 profile should be there. We have created it. So here you have the same thing. You have to, the material is anyway 1060 alloy. So just go to evaluate mass properties. You'll find the mass in gram. You have to enter the value as your answer. That's how you have to answer this particular question. Next comes the assembly. As I told, 2 to 3 modeling, here itself we have clearly mentioned. Drafting, you have to answer 2 or 3 questions. Then part modeling, again 7 to 8 questions will be there. 2 to 3 modeling, the same thing you will repeat it. The same thing we edited ABC or making a circular pattern. This kind of questions will be there. Then assembly will also be there. 2 to 3 to 4 questions will be there. First you have to build the assembly. Then in that they will ask you to change the values. That's what the assembly means. This is one of the question is being given. You can see here there are 3 parts in the assembly. There is a blue color part, pink part, and a green. Four. Sorry for that. The base, wheel component, connecting rod, connecting block. They have named it also. And also unit they have given millimeter gram second. 2 decimal points. Finally, the answers should be in the 2 decimal point. Assembly origin arbitrary, which means you need not worry about the assembly origin. That's what they have given. Okay, so this is how you have to build the model where the constraints parallel you have to give, and this is value B, everything they have given. How it is, this is X, this is A. So what is the idea here is wheel components are mated concentric and flush to the end faces of onto the base. So this is this pink color part is the component. It is made concentric and the faces are flush. Exactly, the faces are flush. That's the first point. Connecting rods are concentric to connector balls on the wheel component. This is the connecting. The green color part is the connecting rod. This is completely concentric. to this wheel, it is concentric. To this wheel, the connecting rod is also concentric. That's what they are telling. Okay, I refer isometric view for locked position of left wheel component. So this is the right wheel and left wheel. Left wheel, they given parallel. Okay, this is exactly matching and it is locked. Okay, then what is the distance of x in mm? What is the distance of x in mm? If we maintain that is A 16 and B is 18 degree. Okay, this is A. This distance we have to find, and maintaining A value as 16 mm. From this edge face to inner face, 16 mm when we maintain, what will be the value of x? Also, one thing they are telling is we have to maintain 18 degree for B. B is nothing but here they have given this B value, this angle as 18 degree. This we are going to build the model. So for understanding, you should take some 2 to 3 minutes. That's not at all wrong. If you completely understand the model, completely understand the requirement, then your assembly time will be completely reduced. During the assembly time, with so much of confusion, if you start building the assembly, later on can we refer, then while building, the time takes very much high. Before that, like how I split up the problem, seeing it, how many parts are there, how many numbers has been used in assembly, where it is used, how the connectivity comes, what is the requirements, everything you understand it thoroughly, spending 2 to 3 minutes in the question itself. Then you open SolidWorks. By seeing the question itself, seeing the model itself, some people will directly enter into the SolidWorks, keep on pulling the model and placing in the model. That won't work here, because here one thing they have told, the assembly origin arbitrary. If I need understand it properly only, I can say that, because origin is no matters for me. Wherever it places, it doesn't matter, because they are asking about this x value which comes within the model. It's not outside the model. There is no relation with the origin. That understanding also you should be there. That's what I like to tell you. Okay, now we going to start build the model. I just enter into assembly environment. Insert component, I go. First, I bring the base. The orientation, I change it here. So orientation is matching. Around the Z. Okay, I consider this isometric view. Orientation I match. Now I can randomly click, because I don't want to go here and make it origin, select here, but still this is the best practice I told. But for this question, I can randomly click also, but you better follow the best practices itself. Then I bring the second part, the pink color part, which is nothing but the wheel component. To wheel component I have to bring here. Insert component once again. Wheel component, I take it here. Go to mate. First I make it concentric. This projection is outward. If you see the isometric model, this projection is outward, like I made. Then these faces are flush. Okay. Then for duplicating this, I hold control and follow the same thing. Okay. I give, and here they have given one constraint. This and this edge is parallel. This line and this edge parallel, automatically it is taken. Next, in the question we have seen here, B value, B angle they have mentioned, right? B angle 18 degree. This and this angle 18 degree. So I constrained all this thing. The third one, the very next step is I have to bring the third part, which is nothing but connecting rod. insert connecting rod, made, select here, select this body. The same thing I duplicate here, made, because you can see it automatically spherically they have cut. So they have mentioned just give the concentric, that is fine. So I do it that. I will insert the other part, connector block, place it here, mate, and make it concentric to this, and also I make it concentric to this. Once I make you concentric, automatically it will get aligned. This both the positions of this and this get restricted. Okay. And one more thing they have mentioned is A equal to 18 mm. Sorry, 18 or 16 mm. Sorry for 16 mm. From the outside, you can clearly see here. Maybe sorry for that. The drawing is slightly big. From the outside face to inside, I have to maintain 16. Mate this outside face and this inside face. I give dimension 16. I have maintained this angle also. You can see here angle 1, 18 degree, and this distance 16 mm I have maintained. Now they have asked me the x from which to which means from outside to inside dimension. So the normal distance is 20.92. That is the answer. That's how I have to complete the answer. They have given 4 options. In that 20.92 is the answer. The next question what they do is maintaining what is the distance of x if a is 18. So earlier we maintained a as a 16. That time you have to change it as 18 and b to 19 degree. This I make it as a 18 and b to 19 degree. I will just rebuild for the safer side and measure the distance. So the normal value is 19.7. Okay, 70. If nothing is there, I have to type 19.70 as a value because I consider 2-digit value only. Since it's completely whole number, it is not showing the second digit. In that case, I have to type the value as 19.70. It is the one of the small assembly. Now, and we came to the last model. With this, I think I can end up the session. We can follow with the Q&A if there is something. Anyway, whatever is there, you keep dropping in the chat box. I will keep on explaining the Q&A. In this assembly, again, the time is also 15 minutes has been given. You start practicing. I can, since it's a demo and I have experience of 10 to 12 years, I can do it in 5 or 6 minutes, but you fix your time. Like for within 15 minutes, this assembly need to be completed, means you complete it. You practice likewise so that quickly you can able to model it. So here also, how many parts in the assembly you see? Whether reference is important. Here you see here, assembly origin as shown, which means it's not arbitrary. You should be careful. The reference might be important. So just read the question properly. There is one linkage base, the yellow color part, and linkage cylinder, the green color part, and linkage piston. Okay, the pink color part, they call it as a piston. Linkage bolt, the violet color part, 3 bolts will be there, and coupling. Linkage coupling is there. So let's see which is the one. Fourth is nothing but the bolts is linkage coupling, which they call, and linkage piston 3. 3 is the piston rod which is entering into the path. Then 5. 5 is nothing but linkage coupling, which is nothing but the scissor lift. This is nothing but a kind of scissor lift they have shown. When the cylinder extends, the scissor lift is retracts and extract. That's kind of a concept it is being made. Okay, fine. We will start building it. I'm closing it without saving. So what is the requirement that I'm still not clear? So I'm just to go through the question. Linkage bolts are mated concentric and linkage coupling cylinder piston holes slots have no clearance. Okay, everything is completely mating and there is no clearance. Bolts are mounted with the head coincided with the piston. Okay, bolts are getting completely coincided with the piston. This area, it is getting coincident, they have mentioned. What is the center of mass if A equal to 60? So XYZ position coordinate system they have given in this. So we have to maintain it. Center of mass if A equal to 60. Center of mass has been shown here. By maintaining the inner dimension, the piston face, inner piston face to the piston wall, if I maintain this dimension as 60, what will be the center of mass of the whole system? Considering this reference coordinate system, that is important. Okay, so I will start building the model. Assembly, insert component, linkage base, so the hole should go towards backside. This hole should go backside. That is the first criteria as per this isometric view. The same way, the orientation I change by clicking this. Then I just go here, selecting the origin. Okay. The next step is I'm bringing this piston part. It is nothing but linkage cylinder part. I give coincident between this to this. The faces should be, so this face should be touching here. Next, I will bring this part. Linkage piston. I give concentric to, instead of selecting edge, always practice selecting the surfaces. Then this face will be touching here. And this hole is centralized to this. For that, what I have to do, I just go use width mate. Going to advanced mate, going to width mate, I select this and select this face and this face. Automatically it will get centralized. The hole will be centralized to this slot. Now still it has the movement between the moving up and down. So what I do is I take a section view. The question they have asked, they have mentioned like I have to maintain the dimension of this A. A is nothing but this distance. The inner, sorry for that, it's not clearly visible. The inner dimension, that is 60 mm. That also I will maintain now. Going to mate, selecting this face, dimension, I will give 60. Okay, I'm exiting from the section view. Then I have to add the linkage rod. insert, linkage, coupling, mate, selecting this, touching this surface. Second mate, I make it concentric to this hole. And I'm duplicating this. Holding control, I drag and place it over here. Then once again, I mate, selecting this face, touching this face, and making this concentric. And also the bottom hole, I make this and this concentric. That's how it has been assembled, right? You can see here, this and this is concentric with this. Here you can see here, this both are concentric, and here is also it's concentric. Then it is projecting from this side, this face and this face is touching. Here also, this face is touching and projecting towards back side. The last part I'm bringing in linkage bolt, giving mate, concentric, selecting this face. Now I use copy with mates. Earlier I have told once, people who missed it, now I am telling it again. Right click here, you'll find copy with mates. Okay, just give this arrow, go arrow, next arrow. So this should be concentric, and the coincident face is this. Right click. Here it got added. The same thing I'm continuing here. The concentric here, coincident face is this. Right click. Okay, like this. Once again, insert. I need not to do this. Copy with mates will save lots of time. Okay, I made everything. Then finally, I insert references geometry. This we have seen already. Coordinate system. We see here x, y, z. X is this, y is upward, z is towards me. X is nothing but this edge, y is upward, z is towards me. Z direction I change it. And the position point is this point I selected. Okay, the orientation you can see here, x, y, z. X, y, z is properly oriented as per the original thing. Then they have asked us to find the center of mass. Evaluate center of mass. Default, change the coordinate system 1, 446.17, 119, 446.17, 119.63, minus 21.04, minus 21.04. That is the answer. That's how we have to answer. The same question they have asked, what is the center of mass if A is 95? Okay, the same thing. What to do is just go here. You have given the distance. If you select here, it will show highlight and show. Double click 95. Assembly, rebuild it, evaluate mass property. This carries less weightage, but still the coordinate system, just see here, it is properly there. You have to type this value 436.01 comma 111.74 comma minus 21.04. If you enter it as a value, the answer will be correct. So hope within 2 hours, whatever I have planned, I have completed. If you have any queries, I'm there to answer for next 5-10 minutes. Meanwhile, if you want to fill some attendance and all, team can share. I don't see any questions. Any more questions? Or just once again, I refresh it. Okay, there are 4 different questions. Will you provide the PPT? Yes, the PPT, all the 3D models which have been shown, everything will be provided. Can SolidWorks version support the downloader? Yes, from 2011 onwards, whichever the file SolidWorks you have, you can download and you can open it during the exam. It will be supported. So whatever I am sharing is also, I will try to share you as a neutral format itself, so that you can able to open it in your system itself, like a step file, a copy kind of thing I will share with you. Will this session recorded? Yes, it has been recorded and it will be shared with you. What should I do for resources? The resources, if you need for section view, broken section, everything, I will do one thing. I will share with this whatever the part modeling I'm sharing. I will share with Mr. Edwin Toyo, so that he will share with you for the sectioning and all, what and all the type of sectioning, what and all the basic knowledge you should have in the drawing part. Those details also I can share you, Mr. Tanvin, so everyone can access to those files also. Can I pass with part modeling alone? No, because 70% of mark is the passing criteria. So both assembly skills also required. What I say is, you can pass my session. You will be getting the downloaded view. Considering the 2 hours session, I have gone bit fast, I understand. But when you get a recorded session, you have an option to pass and understand repeat the same process in your laptop, then you proceed. You might have seen when I was doing, nowhere I struggled, I stopped it, I made something wrong, I just tried to correct those kind of thing. I have not at all done. Everything went with the flow. Same way, you plan properly and go it in a proper flow, you can able to crack it quickly and easily. So meanwhile, the next session also is planned for CSWP. In between, some 2 to 3 weeks time will be given to you. People who want to um, take up the exam, you can take up and pass the exam. Then you attend the CSWP, so that the main idea of this session is not just sharing the knowledge, to make you get qualified, certified from Dassault system, from like CSWA certification and CSWP certification. So you use the coupon code and complete the exam, so that it will be great. When before attending CSWP exam, try to complete CSW exam, so that it will be really helpful for you.
Yes, thank you, Mr. Korobaka, for the wonderful session that you have delivered to
Thank
Uganda
you to
SWAG.
you, Edwin,
And also
and
thank you
thank you
for
entire Uganda
those.
SolidWorks team, who has successfully organized this wonderful session. And so many participants, almost like 27 participants, patiently waited throughout the session. Really, thanks for all of you, each one of you. It's my pleasure to share my knowledge with you all today. And very special thanks to Toya Edwin, who contacted me very long back itself, and provided me the chance to provide a presentation for you all. I hope this association I like to continue. I like to connect with Uganda SolidWorks user group with many other session also in future. Thank you all.
Yes, thank you, Mr. Proba, and the floor will be open, because also I think you also accepted my invitation to present to us CSWP on 17th. 17th, yeah, on
My
17th.
pleasure.
So I'm really grateful for your support from the Champion chapter and SwagNet. Also on LinkedIn, you have been providing a lot of materials to many students. So members, I'm going to upload this I'm going to upload this recording on the YouTube channel, and you'll be able to access it and review it. In the same way, I will be forwarding in the materials that we have used. That is the part drawings, in the same way the PPT.